Okay, this is our first lesson on circles. Day 1, it's section 12, topics 1 and 2 in the Math Nation book. So we're going to talk about circles, which are the set of all points equidistant from a fixed point called the center of a circle. So that just means every point around the circle on the line that you draw, that's the circle, is the exact same distance from the center. We have 3 different types of lines that occur within a circle. The first one is the radius, and I'm going to draw a picture for each. Radius is from the center just to any point along the circle. So I'm going to write on here from center to any point on the circle. The diameter is all the way across. So it's equal to 2 times the radius. It goes through the center. And it goes all the way across. And then a chord is kind of like the diameter, except it does not go through the center. So that could look like, this is the center of the circle. That would be a chord. So the endpoints are still on either side of the circle. It can go through the center, and when it does, that's called the diameter. But it does not have to go through the center to be a chord. Okay, so looking here, the diameters of circles M, N, and Y are 40, 100, and 60 respectively. So we are going to find different lengths within this circle. So I'm going to label this picture. The diameter of circle M is 40. So if the diameter is 40 all the way across, then this little part here is going to be 20. Circle N, the diameter is 100. So I'm going to, the whole thing is 100. And then, let's see, the diameter of Y is 60. So all the way across would be 60. So that means this little part here is 30, half of that. So the first thing that we're going to find is the length of segment ON. So that's going to be this one right here. So we know this whole thing is 100, and so we know that half of it from here to here has to be 50. The radius is 50. So that means that the whole thing's 50. We have 20 already. ON is going to equal 30. Second thing we're going to find is NK. The whole thing's 100. We've got 50 and 30 of it taken care of. What's left over is just 20. Okay. So the main 2 things we're going to talk about today are circumference and arc length. Circumference is equal to 2 pi r, where r is the radius. It is the distance around the circle. So kind of like the perimeter, but for a circle. So an example. If we have a circle and the radius is 7, the circumference is equal to 2 times pi times 7, which is 14 pi. Another example, if our diameter, let's say, is 10, the circumference is going to equal 2 times pi times 5, because that's the radius, which is 10 pi. What you'll notice with this formula is we always multiply the radius by 2. So if you know the diameter, the circumference is just equal to pi times the diameter, or the diameter pi. Okay, arc length. Arc length is part of the circumference. So I'm going to write that down here at the bottom. Part of the it's just part of the circumference. So what I mean by that is if we have a circle and we have just a slice of that circle, we could find right here that I've made a little bit darker, that arc length. It's just part of the circumference. And the way we find that is we know what this angle is in relation to the whole thing being 360 degrees. So theta is just the variable that we use to express angle measurements that we don't know typically. So I'm going to take whatever that angle is, divide it by 360, and then multiply by the circumference, 2 pi r. So an example of this. Let's see. Let's say we have a 100 degrees there, and the radius is 5. So our arc length, which is going to be that length right there, is going to equal, let's call this AB. So arc AB is going to equal theta, my angle, over 360 degrees times 2 times pi times the radius. So in my calculator, I'm going to do 100 divided by 360 times 2 times 5. And I get 2.78 pi. The whole circumference would be 10 pi, but all we want is that highlighted part. So it's 2.78 pi. Okay, so a Ferris wheel is a great way to talk about arc lengths, because the Ferris wheel is obviously circular, and most of the time when you get on a Ferris wheel, you don't go all the way around in one without stopping, because they have to stop and let people on all the time. So the distance that you travel in your little Ferris wheel cart is the distance around a circle, which is the circumference. So we can use the circumference to figure out how far you are going to travel. So when you look at this, you get on a Ferris wheel that has a radius of 60 feet. So I'm going to jot down R equals 60. If you get on and travel all the way around back to where you began, how many feet have you traveled? So you get on and you go all the way around and you're back where you started. That's just the distance around the circle, or the circumference. So we're going to do 2 times pi times 60, which is 120 pi. Or if we plug in 4 pi, 120 times pi, we get 377 feet. If you go halfway around, how many feet is that? So we're going from here, just halfway around, we'd stop at the top. So from here, halfway around, stopping at the top. And take that 377 and just divide it in half. Get 188.5 feet. And then finally, if the Ferris wheel stops once you've traveled 110 degrees, how many feet have you traveled? So this is where our arc length, where we have an angle measurement given to us, is going to come in play. So theta is going to be the 110. My radius stays the same. It stays, what was it, 60. So I have 110 over 360 times 2 times pi times 60. And I could have just gone ahead and plugged in 377 feet for this, because I know that 2 times pi times 60 comes out to 377. I just didn't think about it soon enough to do that. So on my calculator, I'm going to do 110 divided by 360 times 377. And I get 115.2 feet. And that is all there is to circumference and arc length.